Uh, Good morning, good afternoon, good evening. I'm Ali Raza Rizvi. I'm head of IUCN's climate change and energy transition team. So welcome to this webinar, which is the first in a series of sessions we will be having with the experts who would be sharing their experiences on climate change, mainly on climate adaptation, biodiversity nexus, ecosystem nexus. Many of you have been engaged with the Partnership for Climate, Global Affair Canada's initiative. But all those who are not, because this is open to everyone, this partnership has been initiated by Government of Canada, and Carrie Max, our colleague from Global Affair Canada, will share more. So IUCN is partnering with them to work with all the recipient organizations under its program in Sub-Saharan Africa and elsewhere to better integrate biodiversity and climate nexus with gender responsive climate adaptation for effective implementation of these projects. We all know that it's been a big challenge all over the world. At policy level, it's been discussed at UNFCCC, at CBD, CCD, that without addressing biodiversity, climate actions may take towards maladaptation. And it's been the case for the last couple of decades when we see marginalized or siloed approaches are not maximizing on investment. So that's the very purpose of this initiative, as well as this discussion, which will take place every last month of Tuesday of every month. And then we will be working with you. There is an agenda on these which has already been shared and will also be shared with you, all those who are new in joining these webinars. So we will have a very good discussions on that front with our expert. Chief scientist is with us and some other experts also. So I'll go into those details later on. But first, I hand over to Carrie Max from Global Affair Canada to say a few words. So over to you, Carrie.
Thank you, Ali. Good morning, good afternoon, good evening to everyone. It's a pleasure to be able to join the IUCN team in launching this series of what will be likely very interesting conversations and a real contribution to increasing international understanding and capacity to do sort of best-in-class nature-based solutions. And that's why the Government of Canada entered into this relationship with IUCN at the outset. As part of our climate finance commitment, as Ali mentioned, we have a Partnering for Climate initiative, $300 million for programming in Sub-Saharan Africa. We're working with 16 different projects across 26 countries and hundreds of local organizations and beneficiary communities. And we had determined at the outset that our partners doing nature-based solutions should really ensure that they're anchoring their efforts in the global standard for NbS that the IUCN developed. But we also recognize that that global standard was developed as sort of a best possible effort, and that implementing it on the ground, rolling it out, especially in early stages of nature-based solutions implementation and understanding, could be challenging. So NAbSA represents a learning opportunity between Africa, Partnering for Climate, Global Affairs Canada, and the IUCN to see how exactly are we rolling out the global standard? What is the reality of nature-based solutions on the ground? And how can IUCN and the broad donor community do a better job of supporting local partners, local communities in making the best use of nature-based solutions? So in addition to the $300 million in programming, there's a commitment to share knowledge, to promote best practices, and to open opportunities to engage with local practitioners and practitioners around the world. And this series really represents that. So I will leave it at that. Thank you all very much for joining. And please spread the word to your partners and your colleagues that this is happening at the last Tuesday of every month. And they will be recorded, so people should take full advantage of this. Thanks.
Thank you, Carrie. So as Carrie shared that we are working on nature-based solutions and standards, and then how best to effectively, implement it on ground. So that experts will be discussing, and then, and there are different dimensions because, climate is a moving target, as, we all know, and the challenges keep changing. So our response should be dynamic enough to respond to those changing challenges. So today we will have 4 speakers, and so we are delighted that we have, our chief scientist, Thomas Brooks, who will present on importance of incorporating biodiversity in the project work, especially within nature-based solutions, and why strong biodiversity indicators and measures are necessary to realize this. And then we will have Anik Belati, Anik is the focal point for COSME, the conservation and sustainable management of coastal and marine ecosystems. And that initiative has been funded by Global Affairs Canada. And the aim is to cultivate climate resilient economies that empower local communities, particularly women, along Kenya's coastal regions and adjoining transboundary areas of Tanzania. And then Amy Martins and partners will share experiences from Mennonite Central Committee Canada, where they are doing locally led indigenous nature-based solutions for climate change adaptation, and LINKS, which is the abbreviation of that, seeks to improve climate change adaptation for women, men, boys, and girls, and enhancing biodiversity in semi-arid and dry tropical forest, wetlands, and agroecology in ecosystems, and in Zimbabwe. And then Veronica Liu from ISSD, so will be sharing experiences and the project on Nature for Climate Adaptation Initiative, which respond to critical, this issue of knowledge gaps in designing, operationalizing, and monitoring biodiversity positive NbS. So that's the overall flow, and then we will go into question and answers. So now I will invite Tom Brooks and for his presentation. So over to you, Tom.
Thank you so much, Ali. Zoe, can you go ahead and get the slides up? That's wonderful. Thank you. Good day and greetings to colleagues in Canada, colleagues across, I think, a couple of dozen countries through Sub-Saharan Africa, colleagues around the world. It's a huge pleasure, a huge honor to have the opportunity to present the kickoff in this series of NAbSA dialogues, which I think will be serving an extremely important role in addressing the nexus between climate change response and biodiversity conservation. I've been asked to set the stage for the importance of biodiversity for nature-based solutions by providing an introduction to the biodiversity crisis and nature conservation. And I want to start by presenting the message that while biodiversity loss can sometimes feel like a very remote subject, something that isn't happening to us, something that's only happening in some distant forest or remote island, that actually biodiversity loss at a globally significant level is happening all around us. I live in Switzerland, a small country in Central Europe, and even here in Switzerland, we're seeing global species extinctions, global loss of biodiversity. For example, here, the IUCN Red List shows that there have been no less than 5 species of fishes which have become globally extinct from the Swiss lakes over the last century, driven extinct by the introduction of invasive alien species, as well as by unsustainable harvest, unsustainable fisheries. And this biodiversity loss is continuing. For example, the fish species in the top left there, sorry, just hop back a slide there, Zoe. The fish in the top left there is a Zingle asper, a critically endangered fish species now only found in northwest Switzerland and eastern France. Next slide, please. And these kind of anecdotes, these kinds of local and national experiences of biodiversity loss are adding up around the world to present an increasingly comprehensive picture, increasingly comprehensive evidence of biodiversity loss, catching news headlines around the world. Stop biodiversity loss or we could face our own extinction, warns United Nations. As well as mobilizing social protests around the world. Next slide, please. This in turn has raised biodiversity and nature conservation as a response to biodiversity loss up the political agenda, with the Kunming to Montreal Global Biodiversity Framework agreed in Canada last year under the Convention on Biological Diversity, establishing a set of 4 outcome goals for 2050, supported by no less than 23 action targets to be delivered by 2030, all directed towards achievement of a mission of valuing, conserving, restoring and widely using biodiversity, of maintaining ecosystem services, sustaining a healthy planet and delivering benefits essential for all people. Next slide, please. Furthermore, biodiversity is now also reflected into global policy at an even higher level, with the 2015 Sustainable Development Goals for the first time placing biodiversity through targets 14 and 15 at the same level as social and economic sustainability. What though is the evidence documenting biodiversity loss so pervasive as to require such dedicated attention within global goals, within the global community? Next slide, please. To understand the evidence for biodiversity loss, we first need to understand what's meant by biodiversity. And the Convention on Biological Diversity gives a lengthy but really helpful definition of biological diversity as the variability among living organisms from all sources, including terrestrial, marine, and other aquatic ecosystems, the ecological complexes of which they're a part, and including diversity within species, between species, and of ecosystems. So this final clause here, the intra-specific diversity, genetic diversity, between species, species level diversity itself, and then ecosystem level diversity, give us a really helpful framework to look at for measuring, for documenting, for understanding, and for providing the basis to response to biodiversity loss. Next slide, please. Let's first consider the genetic level of biodiversity there. And there are many examples from around the world of the loss of genetic diversity within individual species. Here's an example from the Great Plains of North America, the black-footed ferret, which suffered a severe loss of genetic diversity with a population bottleneck in the 1980s caused by disease outbreaks. Work published just last year synthesized the evidence for these kinds of losses of genetic diversity globally, finding an overall loss of about 10% of genetic biodiversity across species and around the world to date. Next slide, please. Let's move on to think about biodiversity at the species level. And here the key assessment tool is the IUCN Red List of Threatened Species, which has been running for more than 50 years as the global standard for assessment of species extinction risk. It's fundamentally a structured set of rules that allow assessment of the risk of species extinction. More than 150,000 species around the world have now been assessed for their extinction risk on the IUCN Red List, revealing more than 40,000 of those species to be threatened with a high risk of extinction in the wild in the medium term. That's about a quarter of all species that have been assessed. It's also worth noting that that prevalence of extinction risk varies really quite widely between different species groups. And so you can see here, for example, that species groups like cycads, ancient plant species, quite prevalent in many African countries, and amphibian species face very high aggregate risk of extinction, while some other groups like bony fishes and snails and mollusks have a rather lower aggregate risk of extinction. Next slide, please. Here's a specific example. This is a specific example from Latin America, from the country of Costa Rica, where the spectacular golden toad species was driven extinct in the 1980s by the emergence of the chytridiomycosis, chytrid fungal disease. In the graph on the bottom left of the slide here, we can see what's called the Red List Index, which is a measure of the aggregate rate of change of species extinction risk across entire species groups. And you can see a whole set of different species with Red List indices mapped out onto that graph. The position of a given point on the vertical axis tells us the aggregate extinction risk facing species in that group, where a value of 0 would tell us that all species have become extinct, and a value of 1 would tell us that no species are facing a high risk of extinction. And then, given that the horizontal axis is time, and so the slope of any given line tells us the rate of change, tells us how fast species extinction risk is changing. And here, as you can say, especially for species groups like amphibians, that change is a deterioration, is a decline over the last couple of decades. Next slide, please. Let's now move on to consider biodiversity loss at the level of entire ecosystems. A decade ago, IUCN's Commission on Ecosystem Management established a red list of ecosystems, a mechanism to assess the risk of ecosystem collapse, again, in a structured and systematic way. There's still a way to go before the red list of ecosystems has been applied in a comprehensive global way, as you can see from the map at the bottom. But ecosystem assessment has now already been conducted in very many countries. The countries are shaded in red and pink there. The photo on the left here, in fact, both photos show a classic example of the Aral Sea ecosystem on the border of Uzbekistan and Kazakhstan, where the ecosystem completely collapsed between 1985 on the left and 2006 on the right, due to extraction of water for cotton agriculture and subsequent salination. Next slide, please. These biodiversity losses and changes have many direct and indeed many tragic impacts on people, mediated through what are termed ecosystem services, the benefits, the contributions which nature provides to people. Here's a specific example. This is an example from South Asia, in particular from India and Pakistan. And in the 1990s, the oriental white-backed vulture, shown in the middle here, suffered a dramatic population crash. You can see a population index on the right there, a population crash of about 90%, 9 individuals in every 10 dying. And what it turned out was that was driven by poisoning caused by widespread use of a veterinary drug called diclofenac. This in turn has driven a great loss of cultural heritage, in particular of the Farsi people, where towers of silence, shown in the bottom right, were used for air burial and through consumption by vultures. The collapse of the scavenger guild across South Asia has also in turn led to increasing abundance of feral dogs, with emerging evidence that may in turn be driving outbreaks of disease, for example, rabies. Next slide, please. So putting such examples together across different kinds of benefits that biodiversity provides to people, and different kinds of costs that are incurred by people, by societies and economies as a result of biodiversity loss, we can see again some general patterns emerging. On the left here, the global assessment of the Intergovernmental Platform on Biodiversity and Ecosystem Services assessed trends in nature's contributions to people across 18 different categories of such contributions. And what they found is that there have been severe and pervasive declines in ecosystem services, in ecosystem service provision across 14 of those 18 categories of the benefits that nature provides to people, including the things that I've mentioned, like cultural benefits, like regulation of diseases, but also including direct benefits to people, such as climate change mitigation and adaptation. On the left, on the right of the slide here, we can see that if we look at a range of different ways of valuing these benefits, we find a persistent pattern of the greatest relative value, or the greatest cost of loss, being concentrated in the global south, where typically people are least able to afford the loss of the benefits which nature provides to humanity. Next slide, please. So is it all doom and gloom? I've presented a picture so far that really is rather depressing. The parent-student conference here is telling the teacher, don't you think you should relax just a bit? Next slide, please. And I'm happy to be able to report that it's not all doom and gloom. That there are many positive stories, and there is increasing evidence that nature conservation action can indeed successfully halt and even indeed reverse losses of biodiversity and the benefits that it provides to people, consistent with the vision and mission of the Kunming to Montreal Global Biodiversity Framework. Let's again start with a specific example. So the magnificent animal on the left is the scimitar-horned oryx, an antelope species of dryland Sahelian Africa and North Africa. And this wonderful animal has been extinct in the wild for about 20 years now, since about 2000, across its historical range, which is shown in grey here. Over the last couple of years, thanks to really concerted conservation action, with collaborations, international collaborations between the governments of Tunisia and Chad, with civil society, with collaborators in United Arab Emirates and elsewhere, the scimitar-horned oryx has now been reintroduced into a set of protected areas, both in Tunisia and in Chad. More generally, a recent assessment has found that looking across mammal species extinctions and looking across bird species extinctions, extinction rates would have been as much as 3 or even 4 times higher over the last 3 decades in the absence of conservation than what we have actually experienced. We've seen a high level of positive impact of conservation actions in reducing the loss of biodiversity. Next slide, please. And taking this into a still more general context, this is results really quite hot off the presses, published by Penny Langhammer and colleagues in the journal Science just last week, which generalizes these findings. This study reviewed 186 studies, which had compared the outcomes of specific conservation actions across a wide range of different kinds of actions: management of protected areas, sustainable harvest, sustainable ecosystem management, habitat restoration, control of invasive alien species, that compared the outcomes of those actions to counterfactuals, to assessments of what would have happened in the absence of those conservation actions. And this work found through a meta-analysis that conservation interactions across different levels of biodiversity, back to the CBD definitions that we talked about at the beginning, genetic levels, species levels, ecosystem levels of biodiversity, and across different kinds of conservation actions, that typically conservation interventions have a positive impact. Next slide, please. And we can see hope looking into the future as well. This was a study from a couple of years ago, which modeled a range of different biodiversity metrics under scenarios of what the world may look like over the coming decades, over the coming century. The gray lines that you can see here of different runs of these models represent business as usual, and they show continuing declines, continuing biodiversity loss. But what's shown in the yellow scenarios here is much more hopeful. This is the implementation of actions which advance conservation and tackle drivers, the kind of activity which you yourselves are undertaking through this work. And you can see that across those scenarios, there tend to be successful bending of the curve to reduce biodiversity loss and indeed to start advancing its recovery. Next slide, please. So what might tackling drivers look like? This is some work which combined data from the IUCN Red List for mammal species, for bird species, and for amphibian species, to ask what the relative contribution of abating different kinds of drivers would be towards delivering the first goal of the Kunming to Montreal Biodiversity Framework, the specific goal of reducing species extinction risk. And this is measured using a metric called the Species Threat Abatement and Restoration Metric, or STAR, which you'll hear more about over coming webinars. The study found that abating threats from unsustainable agriculture, in particular from unsustainable cropping, unsustainable arable agriculture, offers the greatest opportunity for reducing extinction risk around the world, that there's actually a very wide range of different drivers which need to be addressed through increasing sustainability of production, for example, in terms of forestry, in terms of livestock farming and ranching, in terms of urbanization, in terms of climate change, as well as in terms of control of invasive alien species and control of pollution. Next slide, please. I think this is the second last one, just for time check there. So the species threat abatement and restoration metric is now really quite widely used to provide a quantitative linkage between conservation or restoration or natural resource management projects on the ground with the global goal of reducing biodiversity losses established in the Kunming to Montreal Global Biodiversity Framework, or indeed in Sustainable Development Goal 15. Here, for example, it's used in the IUCN Contributions for Nature platform. Again, this is a tool which will be further explored in subsequent webinars, to document the potential contributions towards global goals, actually including global goals for mitigating climate change as established under the Paris Agreement, as well as global goals for biodiversity, which are delivered by conservation and restoration actions on the ground as undertaken by IUCN constituents. I should also note, I'm not sure if we have any colleagues from companies or businesses joining the webinar today, but the STAR metric is also available for private sector use through the integrated biodiversity assessment tool. Next slide, and this is the final slide from me. So I wanted to leave you with three key messages. The first one, that biodiversity is complex. It spans scales of ecological organization, but it is measurable, and indeed we have the tools and the metrics available to measure biodiversity across genetic, species, and ecosystem levels of ecological organization. Second, that human impacts have already caused a massive decline of biodiversity across all levels and around the world, and across taxonomic groups, across ecosystems. But finally, that all is not lost, that there is hope, that nature conservation, the kind of work which we're going to hear about examples from the ground in a minute, work to mitigate advanced conservation, to address threats and drivers to biodiversity loss, to support climate change adaptation and mitigation, can indeed abate the threats and advance restoration towards halting and reversing the decline of biodiversity loss. We much look forward to working with you all to do this over the coming months and years. Thank you so much.
Thank you so much, Tom. Biodiversity loss, is huge. It is taking place all over, all around us, and efforts, to halt it, they must be informed by the climate change and climate modeling and other aspects. And at the same time, all our efforts which are going on for climate adaptation and mitigation must also be informed by biodiversity data. So that's the critical link. And many people, so many, at the forums, they are all discussing policy, but action on ground is still marginalized. How we are taking action through Partnership for Climate. So now, very briefly, our colleagues from COSME will share their experiences, how they are trying to tackle with this issue. So I'll invite now Anik Belati to share experiences and their efforts on ground. So over to you, Anik.
Thanks so much, Ali, and thanks, Tom, for that really enlightening presentation, giving a very interesting and important global purview. And as you said, this takes now down to the fairly localized level in speaking about Plan International's COSMIC project, which is the conservation and sustainable management of coastal and marine ecosystems. So I know that a number of you, I think, have probably already heard a little bit about this project, perhaps in previous discussions, but maybe just moving to the next slide, I'll just give a brief overview of what the project is and where it's located. So implemented by Plan International with Kenya and with support by Plan International Canada, and obviously a whole host of partners. COSME is in both Kenya, in 65 coastal and terrestrial communities, and in the trans-border regions of Kenya and Tanzania in the Tanga and Pwani region. So as I said, a number of community partners, including seaweed groups, conservation groups, school, women's rights organizations, youth-led organizations, and community change agents, as well as a number of really key government stakeholders. You see the list there. A special shout out to KEMFRI, which is the Kenya Marine and Fisheries Research Institute. I was hoping they could join us today because they're really the ones having led this work on the ground. And they are definitely the biodiversity and eDNA experts, but unfortunately they were unable to join, so you're stuck with me. But just very quickly, the importance of biodiversity in these two counties and trans-border areas of Kenya and Tanzania. The area is a very interesting mix of East African coastal forests, rivers, mangroves, coral reefs. So they really create a unique ecosystem that is recognized globally as a biodiversity hotspot. A number of endemic plants and animal species that are only found in these areas, which we'll see later on in the presentation. And some of these include sacred and ancient forests like the Kaya forests, but all of these ecosystems are under significant threat, as Tom said earlier, due to human activity, so deforestation, fragmentation, overexploitation, and increasingly now the impacts of climate change. So given their importance for the region and the importance for the communities who depend on them, we're looking for strategies to preserve this critical biodiversity in these important spots. So briefly, a little bit more again just about the COSMIC project in terms of its objectives. 3 main pillars to contribute to climate resilient, equitable economies within these coastal areas, especially for women. The first is around our nature-based solutions, so increased adoption, I should say, of NbS with biodiversity and ecosystem integrity co-benefits. The second is around building the social and financial assets of women to participate in and benefit from these NbS. And then the third pillar is around improved climate governance for community resilience. So we could just move to the next slide. And that's next one over, please. Perfect. So what are the nature-based solutions that we are implementing? Well, the first is sustainable seaweed production with women's seaweed groups. So seaweed cultivation in the area is an important and growing, sustainable, if done correctly, sustainable livelihood opportunity for women as the fish stocks have declined. Women are transitioning now as being, in some cases, economic drivers of their households through sustainable seaweed cultivation. The next NbS is community-based forest management, or CBFM, and so this is done more in the terrestrial coastal forests, and then its counterpart, community-based ecological mangrove restoration within the mangroves. Next slide, please. So briefly, what is COSME's approach to biodiversity assessment or measurement? Of course, we're early stages in the project, although we've had an opportunity to complete, or in the midst of completing, some key biodiversity and climate risk assessments. So I'll just take you through those really quickly and some of the preliminary results that we found through this work. So in our approach to measuring biodiversity for the COSMIC project, we've taken a combination of approaches or methodologies. One is an environmental DNA analysis or eDNA analysis, some rapid field surveys, GIS mapping, and a climate risk assessment. So each of these provides unique insights that contribute to a more comprehensive or holistic understanding of the ecosystems within the project areas, which are in that map there, as you can see. And so again, in all of these approaches, we've worked very closely with the Kenyan government, namely KEMFRI, and that's the KEMFRI team in that upper left photo there, who was out in the field collecting samples and conducting interviews over the last several months. So briefly, what is eDNA? Again, I'm not the expert, but I can briefly speak to what we've done in the project. Essentially, it's an innovative technique that allows us to detect genetic material that's shed by various organisms into their environment. So in our case, we sampled soil and water as a baseline, effectively, within its predetermined sampling protocol. to understand what is the state of biodiversity within the project sites in both soil, so land and water environments. So those samples have been collected and been filtered. We're now in the midst of having those analyzed, so that we can basically identify the different species that are present, and I'll show you a little bit about that in a moment. The second approach was a rapid field survey. So in essence, it was to complement the lab-based eDNA analysis, and to give us kind of a rapid idea of the different biodiversities in the different project areas. So teams from Chemfree did desktop reviews, they did transect walks, they set up camera traps, mist nets, basically to have an on-the-ground understanding and observation and to assess the habitats of these different species that were found. So again, sort of a dual approach between the eDNA work, the lab-based work, and on-the-ground work, which helps us cross-check or cross-verify the data with actual sightings and ecosystem assessments, just to give us that bigger and comprehensive picture. So you can see again in the photos here, whoops, sorry, not quite. Thank you. Some samples being taken and some mist nets being taken down as well. The last two measures, we utilized GIS mapping. So we mapped existing spatial data to look at the degradation of forests, both terrestrial and mangrove forests, and to measure the changes in forest cover over time. We don't expect there'll be substantial changes in terms of visuals during the short life of this project, but it gives us a baseline of areas that are available to us for that have been degraded and available for conservation and regeneration. And last, Ali mentioned the critical linkage and articulation needed between biodiversity assessments and climate risk assessments. So the final approach to assessing biodiversity was a climate risk assessment. So looking at the impacts of climatic changes on these ecosystems and critically the people who rely on them. So historical data was collected. We collected indigenous knowledge through key informant interviews with conservation groups, fishermen, beach management units, elders who live in the Kaya forests, businessmen, so a whole host of people who have unique perspectives and a history with these ecosystems. They shared some really interesting information on invasive species. They talked about challenges facing preserving local biodiversity. So we really wanted to make sure, again, we added indigenous and local knowledge into this narrative. So next slide, please. So again, our eDNA analysis is still underway. It's being sent to a sequencing service provider in South Africa. So final results are pending, but what we have found, at least, is here in this slide, which shows at least the DNA concentrations by sample type and site. So whether that's water DNA concentrations or soil DNA concentrations across the various sites that site samples were collected. So I think it's important to note, there's obviously a fair degree of variation in the DNA concentrations that were extracted. Water samples generally exhibited higher concentrations than soil, which is not necessarily to be, it's to be expected. The level of DNA concentrations, from what we understand, are within the range required for sequencing. So that tells us that our sampling protocol hopefully worked, that extraction methods, should be effective. So again, the sequencing and final results are pending, but we do believe on this sort of initial findings that that there was sufficient concentration of DNA to be able to extract and sequence. Just to say, this is why it was really important that we also looked at on the ground conditions. In the second bullet here, you'll see two of the sites, Tankangu and Mwanzaro, showed quite high DNA concentrations in water samples, which you could originally take to mean great, rich biodiversity or higher organizational activity or organismal activity at those locations. But it could also mean, and we believe this might be a factor, that sampling around the time of the El Nino floods, the El Nino rains induced significant flooding in the project areas, which could impact DNA concentrations found in the water. It basically flushes everything from the soil and from terrestrial environments that may not typically be present in water. So time will tell once we have the results to see what type of DNA was actually found. You know, we'll be able to tell whether we think that the flooding impacted the sampling. And also, just to add, this will, you know, have to be taken into account because we're using this eDNA assessment as essentially a baseline, and we'll be conducting it again at N-line at the end of the project to see within the project sites if there's been a change in biodiversity or species richness or variety within the project sites. So the sampling protocols will all have to take this into consideration. Results are pending. We'll let you know. We'll let you know what we found. Next slide, please. So as I mentioned, rapid field surveys, so boots on the ground work was also done to assess the vegetation and bird communities in both terrestrial and mangrove ecosystems, to fill in knowledge gaps that wasn't necessarily in existing literature or drawn from Indigenous knowledge through conversations with communities. And also, like I mentioned, to substantiate, validate, complement the findings of the eDNA analysis. So really briefly, some quick results. So we found a total of 8 mangrove species in Kwale County. I don't know the details, but according to ChemFree, the distribution of species show that there's signs of harvesting pressures on these particular forests. So we'll have to dig into why that is, or how, based on the mix of species, would indicate that. Through the surveys, they did record 157 species from 48 different families of birds. So a number of these are on our species of conservation concern. And on IUCN's red list included the hooded belcher in the picture to the left, which is critically endangered, as well as several bird species that are really only found in coastal East African forests. So that would be the Mombasa woodpecker found in the middle, and the Fisher's turacao on the right. In addition, the researchers found a number of migratory species, some of which are threatened, which call these areas home, you know, at different points in their migration. So again, just to say, a very important ecological area. Next slide, please. So quickly, results from our GIS mapping. Not surprisingly, many of the sites within the counties are heavily degraded, some upwards of 50%. Degraded due to illegal logging and infrastructure and resulting sedimentation, which really affects mangrove forests. So you can see the map to the left there. This is a mangrove forest near the Tanzanian border, and shows images over a span of 20-year period, basically, that were validated by field surveys to delineate the current forest cover and help us identify degraded areas, which are shown in red, where we will be focusing our conservation efforts. Same with the second map, but this is of a terrestrial forest called Buddha Forest, which shows significant degradation along the borders. This is due to human encroachment and droughts and burning during land preparation. And the last shows Mwanga Hills, which used to be a forest, which has now been completely converted or degraded to farmland. So a wide variety of degradation shown in the forests within the project locations. Lastly, I'm getting the note to wrap up. So this is the last slide, or second to last. In terms of the climate risk assessment, so, you know, based on historic data, we found that obviously Kilifi and Kwale counties are heavily exposed to climate change impacts, sea level rise, increased temperatures, changing rainfall patterns. You can see, if you can, on the graphs here, increased temperatures over the years in both counties. Through our consultations, we know that local communities are experiencing, are extremely vulnerable to these hazards, including extreme weather events like flooding and drought, both of which have impacted our project communities. And critically, like we mentioned, this is important information. We need to know how climate change is or may in the future impact local ecosystems and the people within them, so that our biodiversity conservation efforts are sustainable and appropriate for the challenges of climate change in the future. Have a wrap-up slide, essentially. Really quickly, so significant biodiversity within the coastal regions needing protection. An important point here just on integrating Indigenous knowledge, so having ChemFree carry out this work and having it build their own national databases, including the genetic work done through eDNA, super important in terms of informing future conservation and policies. And just to say, we know climate impacts are heavily affecting both the health of habitats and the well-being of communities. So, rapid fire. Thank you so much.
Thank you, Anik, for sharing assessment techniques and other being employed by COSME. So we'll come to some question and answers later on. But now I hand over to Amy Martins and partners to share their experiences working in Zimbabwe through locally led indigenous nature-based solutions for climate change adaptation. So over to you, Amy Martins and colleagues.
Thank you so much. And thank you, Anik and Thomas, for your wonderful presentations. My name is Amy Martins. I work with Mennonite Central Committee in Canada as a project coordinator on what we call the LINKS project, which is the acronym for locally led indigenous nature-based solutions for climate change adaptation in Zimbabwe. You can change to the next slide. So the LINKS project is in partnership with 3 local implementing partners in Zimbabwe: Score Against Poverty, KMTC, and the Brethren in Christ Church Development Services arm. It's also a partnership with different research and technical partners, including the Global Biodiversity Information Facility of Zimbabwe, housed at Bindura University. And so my colleagues from there will be sharing after this, as well as technical support from Canadian Mennonite University here in Winnipeg, Canada, and the National Institute for Science and Technology in Zimbabwe. Next slide, please. LINKS is being implemented in 3 districts of Zimbabwe, so Binga, Gwanda, and Wanizi districts. All areas are within a subtropical steppe climate and dominated by woodlands, including Mopani woodlands. Next slide. The LINKS project aims to enhance biodiversity through 2 different pillars, and this aligns with what Thomas was saying in terms of threat abatement and then also habitat restoration. So first of all, we aim to decrease pressure on forest and wetland biodiversity as a result of human activities. And so this comes into play in the project by strengthening local bylaws and policies for environmental protection and natural resource use, building awareness within communities around sustainable harvesting and use of natural resources such as Mopani worms, providing alternative water sources and cultivation areas outside of wetlands, and then also promoting fuel-efficient cook stoves and alternative energy sources. Then the second pillar is improving biodiversity in forest, wetland, and agricultural areas. And this comes into play through wetland and gully restoration, farmer-managed natural regeneration and revegetation, as well as the promotion of conservation agriculture and other related techniques like agroforestry and intercropping. I'll pass it over to my colleagues from GBIF Zimbabwe, Luke Jimu and Admore Mareva, to talk more about the biodiversity assessment that was done as part of the LINKS project. So you can go ahead.
Thank you very much, Amy. Unfortunately, I don't know what is happening with my video.
That's okay. We can hear you loud and clear, Luke.
Okay, that's okay.
And now we can see you. Thank you.
Oh, wonderful. Yeah, so I'm going to share with you on the work that we are doing, which is assessing biodiversity, linked to the links project. Yeah, so the aim of the assessment that we are doing is to determine the impact of the nature-based solutions that are being implemented through the links project on biodiversity. So we are focusing on all the nature-based solutions that are going to be implemented as part of this project. So these nature-based solutions include conservation agriculture, agroforestry, wetland conservation and management, gully reclamation, forest management, etc. There are quite a number of nature-based solutions that we are actually focusing on. So we would want to assess the impact of these nature-based solutions on biodiversity. And we are looking at various forms of biodiversity, and that includes, flora and fauna, as well as crawling arthropods, aquatic invertebrates, and eDNA as well. And our focus in as far as eDNA is concerned is on the fungal communities and the bacterial communities that you find in soils. Yeah, so we're going to assess all these forms of biodiversity, so the impact of the project on all these forms of biodiversity. And our assumption is that the nature-based solutions will have a positive impact on all these forms of biodiversity. So we're going to conduct these assessments, these biodiversity assessments at 3 levels. That is the baseline survey, midline, and the endline surveys. And I'm going to share with you some of the results that we have so far, that we already have so far as part of the baseline survey. So for eDNA, we have already extracted DNA. We have submitted the samples to our service provider, who is going to do pack biosequencing as well as Sanger sequencing. And we've already started receiving the sequences. Next slide. Yeah, so yeah, the focus, like what Amy indicated, is in the 3 project districts. That's Wenez, Gwanda, and Binga. Next slide. Yes, yeah. So in as far as conservation agriculture is concerned, so we identified farmers that are going to be part of this project. So currently they are practicing conventional agriculture, and they're going to move into conservation agriculture. And also we're lucky to find some farmers who are already implementing conservation agriculture. So in our sampling, we're to select plots in areas where CA is being practiced, and also plots in the conservation, so conventional agriculture plots. So these are adjacent to each other, so as to compare. Next slide. We also, focused on in-field tree diversity, because, in most cases, this is an aspect of biodiversity that is overlooked. So our focus was in identifying especially fruit trees that are of importance to communal farmers in the project areas. And we identified the species and also measured some parameters such as height and DBH, so as to determine the structure of these mini forests in farmlands. Next slide. We also focused on livestock diversity, that is poultry, and also livestock like goats and sheep, as well as cattle. Next slide. Yeah, in as far as forest biodiversity is concerned, we also use some plots that were 50 by 50 to access, the tree species, and also we had some subplots for grasses and forbs, right? Like is indicated in that diagram. Next slide. Right, so we used so in as far as data analysis is concerned, we used species richness, Wayne index, and other indices that we're going to share with you probably later on. But currently we are focusing on the species richness, Wayne diversity index. So in as far as conservation agriculture is concerned, our comparison of plots where CA was practiced and versus where conventional agriculture was being practiced actually showed that in terms of species richness, generally CA plots had higher species richness. And these ones actually included cereals. So this is, in most cases, we are talking about the staple food in Zimbabwe, maize, and also sorghum and pure millet that do well in semi-arid regions, and also some cover crops like groundnuts, roundnuts, cowpeas, and lab. And these ones are quite important because they are nitrogen fixing, so they enrich the soils in as far as nitrogen is concerned. And also some vegetables that are important to the farmers, like Clium, Ginandra, and Amaranthus. So these are some of the crops that were common in areas where CA is being practiced. So we see actually quite a combination of crops that are of importance to the ecosystem, and also to the farming ecosystem, as well as to the farmers themselves, because it provides a variety of food, and also this acts as a source of income for the communal farmers. Next is so for the conservation for the plots where conventional agriculture is practiced, is basically monocrops of the cereals. So it's either maize alone, or sorghum alone, or millet alone. Next slide. Right, in as far as in-field tree diversity is concerned, so generally there is a, depending on the farmers, there is low to high, species diversity, species richness in the farmlands, in as far as fruit trees are concerned. So the fruit trees that are important, that are common also in the communal areas are indigenous, and these include Adansonia digitata, Sclerocaria berea, Zanza gakiana, etc. These ones are important because they supplement the farmers' food, especially in drought years like this year. So they are quite important. And also they generate income, because when the farmers take these fruits to the market, they get extra income. So they play a very significant role in the livelihoods of the communities. In addition to these, also there are some exotic fruit trees that we identify, and that includes mango, and the guava, etc. Next slide. Then in terms of poultry and livestock, species richness also ranges from 0 to 6, right? And they include sheep, cattle, chicken, goats, and guinea fowl. So these are common, poultry and livestock species. But what is important to note here is that the species richness ranges from 0 to 6, which means some farmers do not have poultry or livestock. So through this project, the LINKS project, we expect species richness and the Shinonen index to increase as we proceed with the project. Next slide.
Sorry, Luke, could you conclude also? Thanks.
Okay. Thank you very much. Yeah, so for the forests, species richness also ranges from 31 to 48. So would expect also the LINKS project to have a positive impact on the forest through forest conservation and forest management. Next slide. I think that should be the last one. Thank you very much.
Thank you.
Thank you, Luke. Thanks, Amy and Luke. So now we will move to our next colleague. So Veronica Liu will share experiences about the knowledge products. So over to you, Veronica.
Thanks, Ali. I don't seem to be able to start my video, but that's fine. Okay, so hello, everyone. I'm Veronica. I'm a senior policy advisor at ISD, and I'm pleased to join the other panelists here. At ISD, we've had the pleasure of collaborating with IUCN on learning exchanges through their NAbSA initiative and through ISD's Nature for Climate Adaptation initiative, which are both supported by Global Affairs Canada. So just a little bit about the Nature for Climate Adaptation initiative. It does focus on the biodiversity, gender equality, and social inclusion aspects of nature-based solutions for adaptation by providing technical resources, case studies, learning events, and an online resource library. Oh, there you go. Now you can see me. So we've heard from Dr. Brooks about the critical importance of biodiversity conservation in an era of global biodiversity loss, but also about the opportunities provided by nature conservation and restoration. So in today's presentation, I'd just like to take a few minutes to highlight a couple of resources that we've developed on biodiversity and NbS. Next slide, please. So we've developed these resources, a technical brief and a set of case studies to help familiarize NbS practitioners with the terms biodiversity and ecosystems and ecosystem services that Dr. Brooks also just laid out very nicely for us in his presentation. And to help inform planning, designing, and implementing NbS that enhance biodiversity and ecosystem services, or what we call biodiversity co-benefits. We held a hybrid event on this last June with the AgaCon Foundation Canada, inviting different experts to contribute their experiences and their knowledge. And then we followed that up with some in-depth case studies that are focused on mangrove restoration in Grenada, and also on establishing interurban biological corridors that connect protected areas in the metropolitan area of San Jose, Costa Rica. So you can find all these resources on our website, and I'll provide the link to that soon. But in the next couple of minutes, I'll just provide a few highlights from our technical report. If you can move to the next slide, please. All right, so the IUCN NbS Global Standard provides an overarching framework to guide NbS and to ensure that the intended outcomes of NbS can be achieved through eight different criteria. And their criterion 3 emphasizes net gains to biodiversity and ecosystem integrity. So it's important to consider holistically all these principles in developing and planning and designing NbS. But in addition and complementary to the IUCN Global Standard, the Convention on Biological Diversity has also developed these voluntary guidelines on ecosystem-based adaptation and ecosystem-based disaster risk reduction. And these guidelines were adopted by parties to the CBD at COP14 in 2018, and they provide step-by-step implementation guidance. So here I'm showing just a rough adaptation of the project cycle, starting with understanding the system through to evaluation, selection of options, implementing, and monitoring evaluation. So for our resource, we've taken each of these steps and we provide an additional lens of biodiversity considerations and actions to undertake. If you go to the next slide, please. So this is a big long table. We don't have time to go through everything, but it's just to show that this is a summary of the process where for each step in the EBA NbS for adaptation implementation cycle, we're suggesting specific actions to enhance the biodiversity co-benefits. So the first critical step is understanding the system you're working in and identifying key biodiversity ecosystems and ecosystem services at the relevant scale. And we heard some really interesting examples about this step just now from the COSME project that Anik presented on, with examples of rapid field surveys and camera traps and mapping and eDNA that are really interesting methodologies. And then in step B, we look at how these biodiversity ecosystems will be affected by climate and non-climate risks. Through to step C, when screening for options, ensuring that you're looking at key ecosystems that provide essential services. Step D, when you're appraising the options, ensuring that you're using holistic methods to account for the non-monetary and cultural values of nature in meaningful ways, and that step integrates different knowledge systems and values for biodiversity. And again, we heard from the COSME team just now about how Indigenous knowledge is being integrated by key informant interviews and by interviewing a variety of stakeholders as well. And in terms of monitoring and evaluation, we also just heard from Amy and Luke from the LINKS project team about consulting with local experts to develop their biodiversity sampling design and using different indices in biodiversity monitoring. So those are really interesting examples of monitoring from those two projects. I only have a couple of minutes for this particular presentation though, so in the interest of time, I think the important thing to take away is that in order to generate biodiversity co-benefits from nature-based solutions projects, biodiversity really needs to be considered as one of the central goals of the project, needs to be intentional and additional, And it requires using this biodiversity filter throughout all stages of a project, including from the proposal stage, from developing a logic framework and your objectives and outcome statements, and throughout the planning, design, implementing, and monitoring phases as well. If we go to the next slide, please. I'd just also like to mention that oftentimes we see that a particular NbS is assumed to provide certain kind of benefit to biodiversity and ecosystems, whether it's mangrove restoration or greening a city. But in order to have these biodiversity co-benefits realized, it's really important to explicitly consider biodiversity across the different scales of ecological organization that Dr. Brooks described. So for example, if your intervention is conserving and restoring coastal vegetation and coral reefs to help communities adapt to the impacts of sea level rise and storm surges, then it's also very important to intentionally consider that you're providing habitats for marine life and supporting the nearby mudflat communities that may not look like they have a lot of biodiversity, but actually support invertebrate populations to provide nursery areas for fish and feeding grounds for birds, and to monitor for that extra biodiversity, those extra biodiversity co-benefits throughout the project as well. So in conclusion, we encourage you to take a look at these technical briefs and its appendices, which include a list of NbS implementation guidance according to different types of practices, whether it's agroforestry or ecosystem restoration, and also different tools for each stage of planning and implementation, and examples of indicators as well. And please check out our case studies as well, and feel free to contact me if you have any questions. Thank you.
Thank you, Veronica. You summed it up so well, the discussions and also in your key messages. So that's really good. Thank you for that. So now, okay, if you have questions, this is the time for you all to ask. But at the same time, you may also put in question and answer. And I realize that there is not much time. So you could also write to us, directly also, because it will be a continuous dialogue also, not just ending here, but we will be in touch with you with other capacity building initiatives jointly held, within the teams also, and within the projects and experts outside and all that. So please feel free to contact Zoe or Veronica Ruiz, and also Veronica Liu, because with ISD also, with this initiative, we will be working together. So any question which you may ask our experts, so floor is open. And I see that some questions also were, being put and answered in the question and answer. But it's, end of the day, if I can, ask some, say, Tom, one thing is that, when we go with project-oriented approaches, because there is no other solution,
Bonsoir, c'est le partenaire.
Yeah, please. Yeah, please go ahead.
Bonsoir.
Bonsoir.
Moi, c'est Marega Seydou. Je suis le directeur exécutif de l'ONG Guide depuis la Guinée, Farana, partenaire à CC Guinée.
Bienvenue, merci.
Donc, j'ai suivi avec un grand intérêt cette présentation qui m'a beaucoup informé et rassuré des solutions, sur toutes les approches de solutions basées sur la nature. Seulement qu'on a été, durant tout le processus, victime de l'instabilité de la connexion. Donc, je suis intéressé à ce que vous partagiez les présentations, surtout la version française, pour nous permettre de bien comprendre tout le processus, les items, les éléments que vous avez présentés. Et c'était vraiment très riche de contenu et on vous félicite. Et nous souhaiterons que cela continue parce que tous les jours on apprend et la nature est en train de façonner notre manière de faire, en train de présenter autrement notre milieu de vie. Et donc, il faut qu'on soit très attentif à ça et ce qui me plaît de ça. Donc, pour que nous prenions nos dispositions, nous développons les approches innovantes qui puissent aider nos communautés à s'adapter à ces solutions basées sur la nature. Merci et félicitations à tous les panélistes.
Merci beaucoup, Seydou. Nous avons déjà partagé la présentation en français dans le chat, mais si vous avez besoin qu'on le repartage, on va gentiment le faire, sans problème. Et merci d'être venu voir cette présentation. Merci.
Merci bien.
So Zoe, could you share or gist
Absolutely,
of
yeah.
it?
So, yep. So this was just a request to share the presentation in French, which for our English-speaking attendees and French-speaking, we have already shared it within the chat. And this, from the part of Seydou, was just a big congratulations and thank you to all of our speakers for joining us today. And he thanks us for the very informative session.
Okay. Thanks, Zoe. So the main point is that, please, this as initiative is ongoing and our experts will also be available. So please, send your questions later on also. If, right now you don't have any burning questions, otherwise, still we have few minutes.
Ali, there's a
yes.
really interesting question coming in the chat just now.
Yes, please. Yeah, go ahead, because rather than, yeah, you may answer. Tom, you would like to answer?
So the question is from Samantha Broadley, and it's to our colleagues in MCC and Plan. I wonder if, Samantha, could you intervene directly with the question?
So Tom, we'll just have the speakers answer directly if that's possible, just for ease. Yeah. So
Sure.
Anik and Amy, if you happen to see that question, if you could.
I think this is a very relevant question, particularly for Zimbabwe, where we're seeing incredible impacts on drought currently. And so that has huge implications for the project as a whole, as well as the NbS intervention. So I think this is something like the climate risk aspect is something that we need to consider more formally in terms of how it links with the biodiversity aspect. And I think we're still learning on that piece. So I'm curious to hear from Anik as well as any others who maybe have experience linking the two.
Yeah.
Okay.
Just quickly related to the climate risk assessments, and we've seen in our seaweed activities, for example, the seaweed farms, unfortunately, due to the El Nino flooding that took place a few months ago, a vast proportion, upwards of 80% of the seaweed farmers lost their entire stock. So both it was all washed out to sea, or because of the influx of fresh water, the plants did not survive to harvest. So definitely, I think there was another question in there in terms of projected climate risks and how that was taken into account. Certainly, it's going to factor in heavily in terms of site selection. So again, working with ChemFree and other local partners, determining where any new sites or farms should be set up will be heavily informed by those projections, knowing how catastrophic those events actually can be on the farmers. So that's one area where certainly the climate risk assessments and those projected climate impacts are being factored into how we're going to work with seaweed farmers.
Yes, Tom.
Thanks, Ali. I have a really quick question, if you'll allow me. Actually, further on exactly this point on the linkage between climate change and biodiversity. I was really struck by Ali, your opening comments about the risk of maladaptation or situations where climate change adaptation is actually in conflict with biodiversity objectives. And I didn't hear any examples of such situations from our panelists. I wondered if any of the panelists have come across such situations and how you addressed them, if you have.
Yes, Veronica, you want to say something? Okay.
Oh, sorry, I didn't mean to I didn't mean to
Okay.
unmute myself. But you know, I didn't have a particular answer for this question. You know, based on a project that we're working on or that we presented on. But it is an important, very important step throughout the
Yeah.
project implementation cycle is to very explicitly consider what those trade-offs might be for biodiversity. So agree with your
Yeah.
point there.
Yeah. Thanks, Veronica. And again, Samantha's question and this, are very critical, because what happens at times, when we are developing a project proposal, I have evaluated over 100 projects, in climate adaptation, and I can say with surety that none, and I mean it, none, was, again, biodiversity integrated and, where there was no maladaptation. Because whatever we do, there are trade-offs, as Veronica Lu said, we need to then minimize and weigh them. Okay, what needs to be done? Everything has an impact, whatever we do. So it should not be that only our intention should guide the process. We need to do science-based integrated assessment. So that's the key, and that is the best thing I find about this partnership for climate, where for the first time a donor is proactively integrating biodiversity into climate adaptation measures. So it is very critical, and this is the first webinar, and we will go more into the depth of how of it, because one is, okay, this needs to be done. Other main point is the how this must be done. So we are working on an integrated vulnerability assessment tool also, where we will work with you on other thing, because what's happening currently, we use different socioeconomic vulnerability tools and then biodiversity separately. But integrated models are critical. And then also we need to have those must be implemented, with right resources. And that's the problem at times with project-oriented approaches, that budget has already been developed, activities have already been approved, and then you see changes coming in which must be addressed. So that's what I think the lessons learned we will learn. And then also together with the donors, look, there must be flexibility in project implementation approaches, and that is easier said than done. So let's see how best we move forward on it. But please keep the dialogue on. Please contact us, and based on your feedback, we will, we already have some topics, but we are not rigid with that. We can change those. We can dwell more into this, but these are just the talks. Then we will also be working with you on other, say capacity building or knowledge exchange, but very structured, ways to move forward. There are just a couple of slides looking at the time. Zoe, can you show those, or Veronica? Those are sort of our, next topics. So we will be looking into ecosystem evaluation and cartography aspect. One expert would come from IUCN to talk about it, how it is done. And also we will look for one or two project example from P4C to come and see how they are doing ecosystem evaluations of all this. So again, our colleagues from P4C, projects, it will be first come, first serve sort of, and again, looking into if that's relevant also. So please do contact Veronica Ruiz or Zoe in this regard if you're interested to be part of it. And then you can see there are other also, dates. Last Tuesday of each month, we will be having these talks. But at the same time, we will be in touch pretty soon with other aspects of, knowledge exchange and in-depth structured, workshops, where we will work, like Tom and team will be in touch on STAR, how to do STAR, in what conditions it will be most useful, and how to integrate it, realizing and anticipating you have already been implementing your projects. So all those things, we will be in touch. This is just the beginning, but please do give us feedback. So I will request Zoe to just share a Menti so that we have a very quick. So this is the access code 518-47497. So if you click on the link or on your phone also, So just give us very quick feedback. And then again, as I'm repeating myself, we are not stopping here. Even feedback through email or other, or just contacting directly us. And then also for experts, for any question to them, we will facilitate those, and we can also put you in touch with our experts also. So please give us some feedback so that we can improve on the next one. And while you're doing it, just very quickly, the gist of today's discussion that efforts to date with millions, at times we ask for, there is less money for climate change and climate adaptation per se, but then are we using the funds available to us effectively? For that, it is critical to have an integrated approach. We go with some standardized tools as well as approaches, but flexible enough so that the changing environment, changing climate aspect can be looked into. Also, as Anik was also sharing in Amy, at times things change, and with technology and other thing, local indigenous knowledge is also critical. That technology tells us a broad areas and trends, but at the same time, local knowledge and indigenous, that is also critical. I trust there is a last slide to show. Veronica, Zoe. Okay, so thanks for reminding me. During the margins of the SABSTA in Bonn, we will be having a hybrid, a full day session on sharing knowledge and lessons learned. And that will be the 10th EBA Knowledge Day under FIBA, and partners will be, presenting it. And if you are interested, there will also be marketplace there. We will be having at it just next to the conference center in Bonn, literally 2 or 3 minutes walk from the conference center. So if you're interested in presenting your work there, so we can have a few, P4C also examples to showcase there in the marketplaces. And we will be sharing a whole agenda also with you pretty soon. There will be panel discussion, breakout sessions, and networking reception also in the evening with few ministers will be joining us, and also BMUV. They will be co-hosting it with us together with UNEP and Global Adaptation Network and EBA Fund. So please do join us on that day also. It will be hybrid. We will be having it, some will be there and also online. So thanks a lot, and thank you, Tom, Anik, Amy, Veronica, and also Luke, and especially all the audience also. We had 70 plus participants joining us, so this is great. And as I said, this is the beginning. We will be moving together on this, so your feedback will be very, very critical. And thank you, everyone, and we will be in touch. Please do remain in touch with us on many of the aspects moving forward. Thanks a lot, everyone. Bye.